Good morning, my wonderful chemistry students. Video number 2, focusing specifically now on solutions. A little more in-depth definition style notes for solutions. Solutions are the key part of our unit, so let's make sure we understand each part of it. Characteristics of solutions in general. So let's redo this. Ready? This is kind of in our last notes. They're homogeneous mixtures. They are clear as opposed to cloudy, or they do not disperse light. No Tyndall effect. I'll show you what that means in the next picture, although it didn't come out too good in your notes. They can have color, or they can be colors, but remember, I can see through them. That's what makes them clear. Transparent would actually probably be a better word for that. They don't settle after I let them sit. I shake them up, let them sit them down, and they don't settle out. The stuff that dissolved stays dissolved. Okay, and I cannot just separate them by filtration. Okay, so this picture is better than the picture in your notes because it kind of came out white, the laser in your notes. But this is the Tyndall effect. Okay, so I don't see it in solutions, but I will see it in a colloid. So a colloid is something that looks like a solution, but when I put this laser up to it, if I can actually see the laser beam, I'll do it in green here, right along here. If I can see the laser in the solution, there's something big enough in the solution to make that light bounce around. Those particles that are that big to disperse that light make it a colloid and not a solution. Okay. Solutions always assume the phase of the solvent. So we haven't defined solvent yet, but we're going to do that momentarily. Okay, but it said it was all one phase in the last notes. So what that means is, if my solute is a solid phase and my solvent is in the solid phase, they're both in the same phase. So that would be a metallic alloy because there's a metal generally with a solid. It doesn't say that there's a metal, but we're going to go there. A solid and a liquid. Well, that would be table salt and water would be a good example. Two liquids going together, that would be ethyl alcohol and water. If I take a gas and a liquid, think of your soda pop, take carbon dioxide and dissolve it in water. And then if I mix two gases, that would be something like air. Okay, these are all kinds of solutions. Solutions are made up of two parts. So here we go. Let's name these. Notice they both start with S, so you can easily get the two confused. You need to come up with a way to keep them separated. Okay. The solute is basically the stuff that is being dissolved. It usually starts off as a solid. So in salt water, it would be the salt. Okay. And this is, of course, the lesser of the quantities if I look at them by mass or volume. Okay. The solvent is the stuff that does the dissolving, is what we say. The solvent is usually a liquid, and it is usually in much greater quantity than whatever I am dissolving. Here's a little picture to help us look at this. This is two liquids. I have a purple liquid going into a solvent, turns the solvent kind of a dilute purple, making a solution. Okay. Aqueous. We've heard this and seen this. That is this little symbol. We've been seeing this all year, and we finally get to the point of the course where we get to actually define it. Basically, it's just a solution in which water specifically is the solvent. Okay, so NaCl, A cubed, just means aqueous, means it's dissolved in water when you see that. Okay, so in other words, it's salt water. It's going to, this is what we call dissociate, split into its two ions. NaCl breaks into Na plus and Cl minus, and this is why we found out that ionics conduct electricity. This is called dissociation. And look at that, we're done. We're done with the second notes. I'm going to go back just to make sure there's nothing we missed. Aqueous is basically just a specific, so any solution that has specifically water as the solvent. Aqueous, aqua. So we need to be able to identify the specific parts of solutions, naming mostly solute and solvent. We need to be able to figure out which is which, and we're going to need to know those well, so when we do the math games later doing what we call concentration, we can solve those problems a little bit more effortlessly. Again, no practice for this, no quiz for this, but those are coming in future videos. Be well and have a great day.